Hello and welcome to EVM programming course. This episode will be way more practical than previous ones. We will do a reverse engineering of smart contracts and we'll delve into minimal proxy implementation. So minimal proxy contract is EIP 1167 and this is it. So this is the actual code of minimal proxy contract. So the actual code that does something is this part and this part, because BE is a placeholder for the smart contract address that we will be referencing. So actually let's go and see what it does. In case if you don't know what proxy contracts are, those are contracts that allow you to have a single address that can be upgraded because of use of delegate call. If you remember correctly, if you remember from previous episode, they are using delegate call, and what delegate call is, it's just borrowing the code of different contract while the storage variable and address stays the same. So it's really useful in case if you want to have the same address and the same storage, but upgrade your contract, maybe because you have some kind of vulnerability that you want to patch, or you may introduce a new version of your protocol, or whatever different reason you may have for that actually. And how is minimal proxy useful? The most extensive use of minimal proxy is, for example, in smart contract wallets. So you have the contract, which is logic contract, which tells you how to handle the request for that. However, each user has its minimal proxy with their own address, and because the opcodes are very minimal, it costs barely nothing to deploy this contract, because maybe if you remember from the episode about gas, if you deploy contract, you are paying for all the size of the contract. So this allows for super cheap deployment of new contracts. So I pasted the complete minimal proxy here, and the EVM opcode runtime already changed that to the proper opcodes and added program counter. So let's quickly go and see what it does. If we run it, you can see we first use call data size, which we are checking what call data size was passed to us, and then we check return data size, and we do it twice. And now you may think to yourself, why are we using return data size while we haven't called anyone yet? So this EIP 1167 is created in 2018. At that moment, there was no push 0 opcode. So push 1 costs you 3 gas, and return data size costs only 2 gas. And at this moment, we know that we did not call anyone yet. So return data size always puts 0 to the stack. And this is actually 1 gas cheaper than pushing 0 to the stack. And this is the small gas enhancement that was used before Solidity 0.8.20. Next, we do call data copy. So we are copying everything to memory. And because our call data was just 11, it is put here. Again, we push a bunch of zeros here. We push again call data size and again 0. Now we are pushing our address. This is BEBE as ERC. However, you should put here your smart contract logic contract that will be referenced by the minimal proxy. Then we use the current gas that we have available, and we needed all those zeros and call data size and offset now to call the delegate call to this specific address. So now delegate call finishes. We are checking what is the return data size. So in normal smart contract, it may return some data for you. Here we are duplicating it, 3 stack items down and 1 stack item down. We then copy this data, swap it, check what was the return data size again and swap it, and push to B. Why we push to B? Because this is a location of our jump destination. So as you remember, delegate call puts one element to the stack and it puts whether it was successful or not. So here we duplicated this value and we copied it, and now depending whether our stack element this is the value of success of this call. If this is true, then call to b, which is jump destination, and then in the next step it will just execute return and return to you call data offset and call data size, which we push to the stack here. And if it would fail, it would just continue here and it will call revert. Again, because as I told you, return and revert are very similar, so they will use the same stack values. So the memory offset from which to return the data and its length. In case of this, it was successful, so we are here at jump destination. In case of putting it any other number that would not have jump dest, the EVM will stop execution and return an error, and actually it would return error from the current execution. It would not be treated as the user generated error. It would not have any data inside of it. Of course, this is correct in this case. So we are calling jump dest, and finally we are returning whatever was returned to us. So in case the smart contract would return anything, we will also return the same thing to the caller. And that's it. That is really simple contract, but understanding it really deeply how it works makes you way better at understanding how EVM works under the hood. Even though it was brief, I hope that you learned something new in this episode. This is all for now, and see you in the next one.